Hi, today we're looking at continuous random variable, but before we proceed, please like this video and subscribe to my channel. We have a simple question here that says a continuous random variable has a p.d.f, that is probability density function, given by f of x k into 1 plus cos x. They range from 0 up to pi and 0 otherwise. Compute the expected value. So before we compute the expected value, we have unknown here, that is k. We first have to get this k, and then we proceed ahead to get the expected value, which is the means. So we look at the properties of probability density function, and it states that the integral of all x, f of x, must give us 1. So from here, let's move on and plug in our p.d.f. So this is constant, pull it out, and shall have 1 plus cos x with respect to x must give us 1. Beautiful. So let's integrate. This one comes x plus sine x, and the range is from 0 to pi. So shall have 0 to pi. This must give us 1. So when substitute in x, we shall have our k. This one is now pi plus sine pi, and minus, this is going to be 0 plus sine 0, all give us 1. So this part goes to 0. This is also 0, so we shall have only k pi equals to 1. Dividing both sides by pi, we shall have k equals 1 over pi. Now let's place it back into our probability density function. It may look like shall have k, which is 1 over pi, into 1 plus cos x, and then this is 0. The range here is 0 is less than or equals to x, less than or equals to pi. So otherwise, okay, so we're good to go. The next is finding the expected value, and the expected value is computed from e of x equals to integral of x multiplied by f of x with respect to x. So when you put it in, we shall have our x, and f of x has been 1. We pull it out, this constant, so we shall have 1 plus cosine of x with respect to x. Now when we expand the integral, this is going to be x plus x cos x with respect to x. Interesting. So this part has brought something else, and that is going to be integration by parts. So let's only take that part and first integrate it, and then we'll join it all together. So we have something similar to the integral of x cos x with respect to x. Integrating by part, let me first quote the formula here. We have u dv dx. dx is going to be equals to uv minus integral of v du dx. Now when you look at this, we will take this one, which is easily differentiated, to be u, and this one, which is easily integrated, to v dv dx. So for that, Let's continue. U equals x. So du equals dx. When you differentiate with respect to u, with respect to x, so it means the next one is going to be our dv by dx equals cos x. So when I multiply both sides by dx, we'll have cos x dx, and integrating both sides, this one becomes v and this one becomes sine. Let's not mind of the constant because we're still continuing with our integration. So substituting all this into our equation, that is the integration by parts, we shall have this the integral of x cos x dx will be equals to our u has been x, then our v has been sine x minus the integral v, so sine x, and then du by dx, here instead du by dx is equals to 1, so times 1 dx. So 1 times that is just only sine x, and we continue finishing up that. Copy this one down, we shall have sine x minus integrating sine x, we shall be getting negative cos. So the negative and this positive becomes positive cos x. So we're taking all this on here and place it in to our work here. So let's continue and have our 1 over pi into, this one is x square over 2 plus what we have just integrated here, and that is x sine x plus cos x. Okay, sorry, the range is from 0 up to pi. So putting in our pi in place of x, we shall have 1 over pi, this is going to be pi square all over 2 plus pi sine pi plus cos pi minus, the next one is going to be 0 over 2 plus 0 multiplied by sine 0 plus cosine of 0. So when you look at that, so we continue and have 1 over pi. In bracket we shall have pi square over 2. This is vanishes to 0 and cos pi is negative 1. So we shall have here minus 1. And then here 0, 0. This is cos of 0 is positive 1. And the good news is the 2 are cancelling. So this one cancels out and so just only be left with pi 1 over pi square over 2. So one of the pi cancels, and finally we're just only having pi over 2 as the expected value. Thank you very much for watching. See you next time. Bye.